Right. So Walker cell, El Nino, the N. This is a Spanish word, so the N should have a little tilde on it, but I haven't yet figured out how to put the tilde when I post the video. Maybe I'll figure it out, but you should remember to pronounce it properly as El Nino. We saw this part. Now let's define what is a southern oscillation. Okay, I mentioned Gilbert Walker. He was a British officer in East India Company, as I mentioned. He was a buff in meteorology and did a lot of work, a lot of very, very seminal work. I don't know if seminal is a politically correct word anymore, but nonetheless, very pioneering discoveries. What he found that he was looking at the famines when they happened, and he was looking at the global charts of sea level pressure to see if he could understand where these monsoon droughts and famines were coming from. Okay, droughts and famines are not the same thing, but we won't go into that detail here. So he found out that there was sea level pressure being recorded in Tahiti, where there was a French colony. Sea level pressure was being recorded in Darwin, which was occupied by the British. And he looked at the pressure and found that in general they were out of phase. Why? Because remember that Darwin is in the west, it's in the West Pacific warm pool, which was not defined at the time in the 1900s, early 1900s, 1920 or so. Low pressure at Darwin because it's under warm conditions. High pressure in Tahiti because it's in this cold tongue in the eastern Pacific. It's pretty far south, 17 south, I think. You can check it. He found that there was this pressure gradient, high pressure in Tahiti, low pressure in Darwin, and this oscillated at about 2 to 7 years. And whenever it changed its gradient, then there would be droughts over India. Okay, because Darwin is in the southern hemisphere and Tahiti is definitely in the southern hemisphere, he called it the southern oscillation. Okay, so he found that southern oscillation related to the Indian monsoon drought. Okay, only in the 1960s when Jakob Bjerknes came along and showed that there was this ocean atmosphere feedback between winds, upwelling, thermocline, temperatures, warm pool, convection, and so on, that the people realized the two are actually the same thing. And then it became El Nino, Southern Oscillation, or ENSO. So in this figure you can see that as the warm water sloshes eastward, the western part of it gets anomalously cooler, so cooler than normal. The eastern side becomes anomalously warmer, so warmer than normal. Upwelling is reduced, trades are weaker, and so on. Thermocline is deepened, and the warm water has basically been dispersed as opposed to being piled up in the west. But you can see in this cartoon here that the convection, or the rising air and rainfall in the west, is also migrated eastward. Okay, so we will see slowly that the anomalously colder temperatures in the west make for way below normal rainfall over Indonesia, parts of Australia. They lead to dust storms and so on and so forth because of this drying, forest fires, etc. There are human factors involved, but nonetheless. And in the east, all the way from South America, Central America to North America, you begin to have anomalously warm temperatures and anomalously wet weather. Remember, California coast is cold, dry, but during an El Nino, during the winter months of El Nino, it begins to get lots of rain and mountain snow and so on. In fact, you begin to have floods and mudslides and so on in parts of Chile and Peru and so on. The upwelling is reduced, nutrient supply is reduced, so you will have also reduced primary production, which means reduced fisheries, which means dying seabirds, and so on and so forth. Okay, the entire food chain and the entire seasonal precipitation patterns get disrupted, not only in Western Pacific and Eastern Pacific, but also everywhere, because 5 meters of rain in the West Pacific is a massive, massive heat source. When you move the heat source, It changes the Hadley cell, changes the Walker cell all the way across the tropics, all the way into the subtropics and higher latitudes. Okay, so that's the story of the southern oscillation, and that's the story of some more details of what actually happens when the El Nino Southern Oscillation, or ENSO, happens.